Good morning, pre-algebra. Today we are going to be factoring linear expressions, and this was going to wrap up our chapter 7. We've been working with linear expressions, so today we're going to be factoring. So our starting point for factoring linear expressions is reviewing greatest common factors, how we find a greatest common factor, and in particular how we find greatest common factors in a pair of monomials. So let's go ahead and take a look at that. Here we have an example of 4x and 12x. Notice this is a pair because there's a comma there, right? And so we have this pair of monomials, 4x and 12x. When we look for the greatest common factor, the way I've been doing it for you on the board, is we ask ourselves, what can we divide this by, right? And we're just going to divide it out into its smallest number, a number that cannot be divided into something smaller. So 4x, well, obviously that is 4 times x. So the first thing we have is we have an x. Okay. Now let's deal with the 4. What can 4 be divided by? And we're not going to start with 1, because if it's 1, then we know that we're at the end. And depending on what the other number is. So let's start with 2, and we'll work our way up. If it's not divisible by 2, then we're going to move up to 3. So is 4 divisible by 2? And the answer is yes. It's divisible by 2 again. Is 2 divisible by 2? Yes, the answer is 1. So that means that we are now done. So we factored 4x into x times 2 times 2. Now let's do the same thing with 12x. So again, 1x, so we'll have that there. Okay. And now 12. Is 12 divisible by 2? Yes, it is. And what do we have left? Well, we have 6 left, and I'm just going to write that over here, up here in a different color. So 6. Again, 6. Is 6 divisible by 2? Yes. So if we divide 6 by 2, now we have, let's cross out that 6, now we have 3. Is 3 divisible by 2? No. Is 3 divisible by 3? Yes, that answer is 1. So that means that we have a 3 left over. So now, what is, for 4x and 12x, what is the largest number that can go into both of them? And so we just start looking for similar pairs here. Well, we have a pair of x's. So we know that x is going to be part of our GFC. We have a 2, and we have another set of 2. And we have a 3 by itself for the 12x, and we have nothing left for 4x. So that means that our GFC for this pair is 4x. Okay? So let's try the next one. We'll erase what we did there. All right. So let's try the next one. 18a and 20ab. So let's start with 18a. 18a equals, we'll go ahead and do the a, times 18. Can 18 be divided by 2? Yes, it can. 18 divided by 2 is 9. I'm going to write that up here just so we can keep track. Okay, so by 9. So now we're dealing with 9. Can 9 be divided by 2? No. Can 9 be divided by 3? Yes, it can. So our next factor is going to be 3. And that means now that we're working with 3. Can 3 be divided by 2? No. Can 3 be divided by 3? Yes, by 1. So we are going to write, that means that this is another 3. So that means that the factors that go into 18a are our smallest factors are a, 2, 3, and 3. And if we were to multiply those back together, we would have 18a. So now let's deal with our second one, 20ab. Okay, let's deal with the variables first. We have 1a and we have 1b, and now we're dealing with 20. Can 20 be divided by can 20 be divided by 2? The answer is yes. 20 divided by 2 is 10. So we're going to write our 2 here, not our 10, our 2. We're going to write our 10 up here to keep track of what's going on here. So now, can 10 be divided by 2? The answer is yes, it can be divided. Again, the answer is yes, it can be divided by 2. So we write another 2, and now we're at 5, because 5 times 2 is 10. Can 5 be divided by 2? No. Can 5 be divided by 3? No. Can 5 be divided by 5? Yes. So that means we now have a 5 here. And again, we can check our work. 5 times 2 is 10, times 2 is 20, times b times a is 20ab. So now what we need to do is we found the smallest numbers that go into 20ab. Now we need to find the greatest one that matches the greatest number that goes into 18a. So let's start circling pairs in our list here. So we have an a in both. We have one set of 2. We don't have a b, and we don't have any 3s. We don't have any more 2s or 5s up there. So that means that our greatest common factor for this set of 18a, 20ab, GFC, the largest number that goes into both, is 2a. In this case, the 2 things that we circled. Let's try 2 more. $12 and 28C. Again, 12, can it be divided by 2? Yes. 12 divided by 2 is 6. So we're not going to write 6 there. We're going to ask ourselves, can 6 be divided by something? So again, I'm writing 6 up here just to keep track. Okay, so 6. 6 can be divided by 2 again. So we'll add another 2. Cross out that 6. Now we're at 3, because 3 times 2 is 6. Can 3 be divided by 2? No. By 3, yes, once. So that means that 3 is our last number that's going to go there. And again, if we were to multiply these 3 factors together, 3, 2, and 2, we would get 12. So we know that's correct. All right, so we're done with that one. Right now, 28C. Again, we can start with the C, get that one out of the way. Okay, so now we're just dealing with 28. Can 28 be divided by 2? Yes, it can. So 2. 28 divided by 2 is 14. So we're thinking about 14 now. Okay, so now what can we do with 14? Is 14 divisible by, what's the smallest number that 14 is divisible by? It's divisible by 2 again, because 2 times 7 is 14. So now we're working with 7. What's the smallest number that 7 can be divided by? Now in this case, the smallest number is 1, because 2 and 3 and 5 don't go into 7. So that means that this ends with a 7. So our factors, our smallest factors for 28C is C2, 2, and 7, because 7 times 2 is 14, times 2 is 28, times C is 28C. And the smallest factors, the smallest numbers that go into 12 are 3, 2, and 2. So now we're just going to look for common pairs. So starting with 12, do we have a 2? Is there a 2 down here? Yes, there is. So there's one set. Another 2. Is there a 2 for 28C? Yes. So there's another set. 3. There's no 3 down there. And that's the end. Just double check. There's no C in the 12, and there's no 7 in the 12. So that means that our greatest common factor, again, we're looking for the largest. The greatest common factor is not the smallest number that goes into it. It's the largest number that goes into both. And so in this case, it's going to be 2 times 2, or 4. So our answer for this one is going to be 4. All right, so let's try this one. 42mn and 14mn. And I used black there. I didn't necessarily mean to do that, but we did. All right. So again, m times n. These are pretty easy to do with the variable that doesn't have any kind of exponent. It's not like m squared or m to the 5th or something like that. So these are pretty easy to start with. Okay, so let's finish off with 42. Can 42 be divided by 2? Yes, it can. So 42 divided by 2 is, we'll use green now over here, 42 divided by 2 is 21. Can 21 be divided by 2? No. Can it be divided by 3? Yes, it can. So we're going to write a 3 here. And now 21 divided by 3 happens to be 7. And we just learned, right, from up top that 7 can't be divided. The smallest number that can be divided into 7 is 1. So we are done. And again, we can check back. 7 times 3 is 21 times 2 is 42. Or 2 times 3 is 6 times 7, also 42. All right, so down here for 14mn, we're going to do the same thing. Can 14 be divided by 2? The answer is yes. And that leaves us with 7. Oh, well, we've already dealt with the 7, so we know exactly what's going to happen here. All right, so now we look for pairs. There's an M in both, and that was not orange. I was wanting to use orange. There's an M in both. There's an N in both. There's a 2 in both, and there's a 7 in both. So that means that the greatest common factor for 42mn and 14mn is 7 times 2, 14 times m times n. And that's our greatest common factor. All right, so what happens when we have a linear expression? Remember, a linear expression is a set of terms, right, that we are being asked to add or subtract like we've been practicing before. So how do we factor it out? Well, we use the distributive property and we work backwards and we think backwards, right? We want to take what ends up being what we call the product, which would be this one here, and we want to kind of write the equation, so to speak, which is this one here. We're trying to go from here and going backwards to here. And that's what our attempt is going to do. So how did we do that, since I already gave you the answer here? Well, let's take a look. We have 8x plus 4. So we have let me make that x a little better there. So we have 2 pairs, right? We have 8x and we have 4. Well, we can just do what we were doing, look for greatest common factor. And notice, and what's going to happen is the greatest common factor is going to be outside the parenthesis. We're going to see that happen here. So we're going to take the greatest common factor out of these 2 terms. We're going to leave those 2 terms in their algebraic expression of something x plus 4 if x remains. And then we're going to times it by the greatest common factor. So let's take a look here. So up here for 8x, we know we have an x. 8 is divisible by 2. Yes, that leaves us with 4. And 4 is divisible by 2, which leaves us with 2 and 2. So 2 times 2 is 4, times 2 is 8, times x, 8x. 4 is 2 times 2. So look for some sets. There's one set of 2's, there's another set of 2. So that means the G of C is 4. So we're going to take that 4 and we're going to write it 4. Now we're going to do open parenthesis, right? So we're going to take 4, we're going to divide 4 out of 8x. That's going to be 2x. Notice, what did we have left up here? We had an x and a 2 left up here in our 8x. That is the same thing. Okay, so what we had left over is going to go inside that parenthesis there. We check our equation. It was a plus, so we're going to go ahead and write that plus inside the parenthesis. So we have 4 open parenthesis 2x plus. What did we have left over down here? For 4, nothing. So we're not going to write 0 because 0 is not the right answer. We actually have, although we didn't write it, we have it times 1. So we have 1 left there. And so that means that we have 4 open parenthesis 2x plus 1 close parenthesis. Right, so we have factored out the greatest common factor, which happened to be 4 here. That's outside the parenthesis, and then we have what's left inside the parenthesis. And that's how we factor 8x plus 4 into 4 open parenthesis 2x plus 1. So let's try a couple more. 3x plus 9. So 3x and 9, because we're going to find greatest common factor first. X times 3 times 1. Right. I'm going to put that 1 there just to help us remember that if something comes out like we had there with that 4, right, if there's nothing left, there's still a 1 left. It's not a 0, it's a 1. And then 9, this is pretty simple, is a 3 times a 3 times a 1. So what do we have left? Well, let's look for our sets. A 3 and a set of 1. We're not going to really worry about that 1 when we end up writing all this together, but we'll go ahead and keep it there. So that means our greatest common factor is 3. So we're going to rewrite 3x plus 9 as 3 open parenthesis. So what was left in our 3x? Well, all that we have left is an x and that 1, but since we have something else there, we're not going to write the 1. Plus, and what was left down here in our 9? Just a 3. So we have 3 open parenthesis x plus 3 close parenthesis. Notice again, I'll choose a blue color here, right? The 3, that's that 3, the leftover, the x is that one there inside the parenthesis. Okay? So let's try this next one. 15x and 18. So 15x, we'll go and start with the x. 15 divided by 2, not possible. 15 divided by 3, 15 divided by 3 is 5. 5 divided by 2 by 3, nope. It's by 5 and by that 1. Okay, 18 divided by 2. Yes, we can do that. That leaves us with 9. And 9 is 3 times 3. Those are the smallest numbers. And then we have that 1 there as well. All right, so let's look for common sets. 3. Interesting, right? all that we have is we have a 3. That's our common set, which means that that is our greatest common factor. So for this set, our greatest common factor, and I've been writing that expression wrong. Look at that. I've been saying it right. Greatest common factor is GCF. This is GCF. I've just been using the wrong letters there. Is 3. So we're going to write it over here as 3, open parenthesis. What did we have left here for 15x? We had a 5 and an x. Plus, use the same sign as we had over there. Right down here we had a 2 and a 3, so 2 times 3 is 6. And that is our factored expression there. All right, our last one. Oops. Our last one is 4x plus 35. We're going to be asked to factor this down. So let's start with our 4x. 4x is x times 2 times 2, because 2 times 2 is 4, and then that times 1. Okay? And then 35. Can 35 be divided by 2? No. Can 35 be divided by 3? No. Can 35 be divided by 5? Yes. And that happens to be 7, which is not, there's nothing smaller that goes into 7 other than that 1. So now we look for common sets. Any x's? No. Any 2's? No. Just the 1. But we're not really concerned about 1's. We're not going to factor 1 out. We're not really concerned about that. That's only important if 1 is the only thing that's left. Okay, so guess what? For the answer here, our answer is cannot be factored because there's not a common factor that goes into 4x or 35. So there's nothing we can do there. I mean, we checked it. We factored out 4x and we factored out 35. We looked for the greatest common factor, but there is no common factor between those two. So the answer to a problem like this is that it cannot be factored. All right, that is it. We have covered all of our examples. And so it's now time for you to do your work. This will be lesson 7.5 homework, and Alex.